All right. What's the premise here? Who's who and what is going on?
All right. Well, my name's Aaron. I've interviewed you. I interviewed you a couple of years ago, but you've done like I think just short of 727,000 interviews in the past
It's a little
couple of
less than
years.
that, but not much. All
But yeah. So my name's Aaron Barker. I am a like an 81 percenter on the flat Earth. I
right,
know
that's cool.
something's
Cool.
going on. And Erica is more skeptical, so she's going to have some more. I'm going to be eating everything up. Erica's going to be a little more skeptical and challenging on some of her questions.
Fantastic.
So. Welcome, everybody. This is the Breakdown Declassified. Thank you all so much for joining us this evening. Those of you who typically subscribe to the show, we are opening this particular episode up to a boatload of people because it's going to be fantastic. I'm super excited about our guest that we have. We have Flat Earth Dave. Dave Weiss is joining us on the show. How you doing today?
I'm doing great, Aaron and Erica. Thanks for having me. This will be a fun conversation for sure. You said
Welcome.
81% flat Earth and Erica is 50-50? Less than 50?
I feel like I might be 30-70. Like 70% the earth is round, 30%
Well,
I'm
okay.
listening. I don't
Let's see what
know.
happens. Let's see
Help
what
me
happens.
out, Dave. Come
No
on.
problem.
Now, do you mean round or do you mean globe? Because
Yeah.
those are two different things.
I mean globe. You know what I mean. I'm not trying to get on a third side of this whole debate,
I'm going to
right?
ask you something, Erica. Are you ready? It's
Yep.
riddle. It's very easy. If
Okay.
something doesn't curve, then it's what?
What?
Okay. And if something doesn't move, then it's what?
Well, if it doesn't move stationary.
There you go. Okay. So just remember that as we go along here.
Okay.
All right.
Now, first, you have the app, which is on display behind you there.
Yep.
I have it on my phone as well. Is this going to be updated? Because I still have the black widget, and it's all black. It doesn't have the clock.
You have to update that. You have to update it. Then there's another update coming in a couple of days. But we switched servers a while ago. It doesn't sound like you switched servers. So just go to the App Store and click update, and then you should be good to go.
I'll do that.
And there's a couple sections: the profile section, the matchmaker, which is the dating, and the meetup maker. Those are all being updated right now. So it's going to be a couple days before they're fully back online. So there'll be a pop-up telling you that just stand by while we're updating.
Awesome. Well, let me do this. So real quick, that meetup thing, because I'm married, so I don't need the single thing. But the meetup thing, just give me an idea and show the audience here how many people, like if you just pulled up how many people are in the app and where they are. I mean, it is incredible the amount of folks who are catching on to this or at least starting to pay more attention to what's happening here.
I will just real quick. The meetup maker and the friend finder, that's two different things. The meetup maker is you can create meetups and then it'll create a nice little poster for you with all your information and people can swipe by it. But I'm going to point this out on every show is you have to go down here and say, alert me of local meetups. And you say, okay, within whatever radius you select, I want to be emailed if someone sets up a meetup. So Aaron, let's say you live, I don't know, 25 miles from me and you set up a meetup. I'll get a notification. Hey, there's a meetup on Saturday, 25 miles from me. And it'll come to my email and I'll be like, oh, because so many people miss these meetups. And it's super, super fun. So going to
like a biker meetup. I mean,
well, no, a meetup like
in theory, like you just hang out.
a book club,
Okay.
Book
All
club.
right. Okay.
And everyone that shows up is quite amazing. So these are just the people that are around me. And, I can click on somebody and I could look at their profile. I can send them a message. But right now I have it set for, 50 kilometers. And in 50 kilometers from me, there's 438 people right here. And if I click that, I can send a message to 438 people. Hey, I'm having a meetup at Tony's Bar and Grill Saturday at 4:00. Stamford, Connecticut. Send, and then everyone in that circle will get a message on their app letting them know that there's a meetup.
So let me ask. So because of that, there are a ton of people there. And Erica, anytime you have questions, please jump in and just ask.
Are they all flat Earth people?
These are all flat Earth people that have the app. And I would say this app represents less than 1% of the flat earthers out there. Right. So look, this is the Northeast here. These are people that have my app that are like-minded. And let me tell you something, single or not, a friend that's a flat earther that's like-minded is better than normie world.
And I think that's so when you're meeting these people and you're doing all these interviews, are there a lot of folks that are like, absolutely the earth is flat, or are there a lot of people that's just like, I don't know if I'm fully committed there, but I know that something is amiss, something is going wrong, or
Well,
something.
it's hard to say, but by me telling you the percentage of the interviews that I have, if they're flat or not, that all depends on who I'm reaching out to and stuff. But in 2014, every single podcast I'd reach out to would say you're absolutely crazy, and I'm not even having you on because you're totally ridiculous. And when I say ridiculous, it's the other R word I'm saying. And now, if I mention flat Earth to somebody, people are like, I've heard something about that. I'm 81%. I'm 30, 70. There's so many people asking questions, and there's so much bad publicity going around about flat Earth, right? Which is crazy, but all publicity is good publicity when you're in the truth. And the truth is, we don't live on a spinning wet rock water pair in a space vacuum. The heliocentric hypothesis is actually the most retarded. Am I allowed to say that word?
Yeah.
You're allowed to say whatever you want to.
Yeah. Okay. I say frigging ridiculous. I really mean
retarded. It's all right. You can say it. I'm down.
Okay. I try to keep it clean because kids listen and stuff.
I guess.
Yeah, but I'm okay with that word. That word's a great word.
I have so many questions.
We can start off with Flat Earth 101, but let's not do that. Let's start off with, why do you think the Earth is a globe, Erica? What's your the one thing that keeps you at 70%?
No, the worst thing ever is that it's all I know. It's all I know.
Well, because that's what you were told. You believe that. And
right.
And when you went to school, it was all about the kids are in first grade or kindergarten. They're bringing home the moon goes around the earth goes around the sun. They're marching around. It's someone's birthday. They're like another trip around the sun.
Listen, we all had to make a 3D model of the solar system in 7th grade in order to get out of Earth science, right? And then when you order a globe, it doesn't come as a flat mat that I unroll and put on my table. It's round and it's on a stand and it spins.
Do either of you have a globe in your room with you right now?
I don't.
But next time you go in a store and you see a globe, pick it up and look at the sticker on the bottom. And it says, for decorative purposes only, not for education.
So I mean, it's the worst excuse ever, Dave. It's that it's all I know. And then I intertwine that with stuff like, I mean, we've been up there. Like, hasn't
been up there? Like up here? Like on the moon?
But you're gonna say no, we haven't been up there, so there's no, like, in my mind, I'm saying, isn't it easy to prove either way? Like, no, why can't we just go up there and look down and go, it's flat or it's round?
Because you can't get up there. There is no up there. No one's been to the moon. The moon's not a place you can go. But they did just say they got a new photo of Earth. So this is the new photo here. And when we put the old photo over it, did the Earth turn into an egg since they took that last photo? Can you see? Look at how did we get so? That's a couple thousand miles, that hump. Okay. How did that happen? How did that happen?
Does Neil deGrasse Tyson just invent new shapes of the Earth whenever something like that pops up? Like now it's parabolic or something like that?
Yeah, parabolic. So check this out. Here's the United States, Mexico. You see, so this is the 2012 blue marble picture, right? We got Florida. So we got America here, and we're looking at the full circumference of the Earth here, and we line it up with the map. All of this other map has to be on the other side of this. But if we go to the other side, where we got Africa, and we look, here's Africa, right in the spot, all of this, how come all of this isn't showing up on this side? So this proves to you, for anyone that has a thinking mind, that both of these are fake. There are no photographs of Earth. Find me where NASA says, here is a photograph of Earth. They don't. They say picture, they say image, but they will not say photograph because they don't like to lie.
Yeah, I'm on board with them both being fake. That makes sense.
Yeah. Well, so we have pictures of Pluto, we have pictures of Venus and Saturn, but when we take a picture of the Earth and we line it up with the map, do you believe that the rest of this is on the other side of this picture? Do you believe that?
I mean, currently, yes.
Well, how explain how that can be? How can all of that fit on the other side?
I can't explain how all of it can, well, I can't explain how it can fit on the other side. But
So,
then I
so
look at if I'm standing at the North Pole and I'm looking at the sky, or I'm standing at the South Pole and I'm looking at the sky, why am I, or anywhere?
why you see
I
different
mean,
stars? Is that where you're
yeah,
going?
like given there's a there's some trajectory, right, that would say I can only see so far because I can only see so far.
Well,
So if you're all the way, even if it's flat, right, and I'm here,
what are you
you're,
saying? What is your question? I don't
why
understand.
aren't we looking at the same thing?
What are you talking about? Different stars?
Or just, yeah,
Like
yeah,
let me
because the
steel man
stars
the
would be the
argument for
only thing
you.
you could
The
use.
stars in the south aren't the same as the stars in the north. You can't see Polaris or North Star from the south, right?
Right.
Okay.
Right. But if it
Well,
was flat, wouldn't I be able to see? Wouldn't we all be looking at the same thing?
well, that's if you believed in a heliocentric world with incredibly distant stars that are so far away that they would never merge into the horizon. But the truth is, the stars are within our atmosphere, whatever they are. We don't even know what they are, right? And we'll get into that in a minute. But imagine you and I are in a room, okay? We're in a room. It's got nice tall ceilings, 15-foot ceilings, and there's recessed lights, all random lights. And you and I look up and I say, look, there's a starfish and there's a horse and there's a dragon. And you're like, yeah, I could see that, right? Like when you look up and you make patterns, right?
Right.
So now we're going to expand that room to the size of New York City, miles across, right? And I say, okay, Erica, go for a walk. Before you get 500 yards away, I can't see you anymore because the ceiling and the floor have merged together due to perspective.
Right.
Okay.
Right.
And so now you keep going, you're a couple miles away. I yell, you can't even hear me. I call you, you answer the phone. I say, Erica, can you see that starfish? Can you see that dragon that we were looking at? You look up and go, no, I see completely different lights. I can't see the lights that you're looking at. You can't see the lights I'm looking at. It's all due to perspective. And in the flat earth, the sky is very low. The sky is very close. And everything merges. Look, let me ask you a question. Are the lights at the end of the street below the horizon? No, they're not. They're all the same height.
No, they're the
They're all
same.
the same height, but they
Right.
look like they're merging into the horizon. Here's the sun. Is the sun below the horizon? Right?
No.
You know, okay. So I'll put this truck here, and now you can see that these lights are behind the truck. They're beyond the truck. They're not below the
Right.
truck. They're beyond the truck, but the truck is blocking them, even though they're higher than the truck. Right?
Yeah.
Okay.
Yeah, I
So
get
now
that
I
because
move the
they're
truck farther and farther and farther. Eventually, that truck gets wedged into your horizontal eye zone. What how can we shorten that? Horizontal eye zone. What can we call that? Horizontal eye zone. Horizon. Oh, into your horizon,
Oh, okay.
right? Which comes from horizontal. And are these lights going beyond the truck, just like they were closer? Sure. So that line that you call your horizon is a combination of land features, atmospheric features, clouds, that's the atmosphere, and it all gets wedged into that, and the sun just goes beyond it. Right? Do you know on your ball, on your heliocentric religion, how much curvature there is at 3 miles? Just 3 miles. Doesn't seem like far, right?
I mean, it feels far to me. Like if I'm
How
going
much
straight
curvature? So
up,
you're
yeah, I think
standing, no,
that
no,
seems
you're
really
standing
far.
at the edge of perfectly calm water on a perfectly clear day.
Right.
How much earth curve drop is there at 3 miles away from you?
I don't know.
It's 6 feet.
I mean,
So
oh,
let me ask you a question. Let me just follow this through. Follow this through. So a 6 foot tall person standing at the edge of perfectly calm water with no waves will see the earth curve. The water beyond 3 miles will be below where his eyes can see. So there'll be a physical horizon, right? And at the farther you go, the more it'll drop down. At 10 miles, it's 66 feet. So what state are you in? Where are you at?
I was just going to say that. Right now I'm in Indiana and I'm trying to compare what you're saying with
Have you ever watched the sunset over the ocean, like California, Hawaii, or anywhere?
Oh yeah, absolutely.
So
Yeah.
if you're standing at the beach and watching the sunset, that intersection with the horizon, which you think is physical Earth curve, is that less than 3 miles away? Because you're not 6 feet tall, so it'd have to be less than 3 miles away. And if you were sitting, it'd be like a mile and a half away.
That's not possible.
It's not possible because it's not possible, right?
That's not
And
possible.
it's not possible, but on a globe, it's required, right?
Yeah, it would have to be. It's like
Required.
sitting on the beach and
The
being able
sun
to
goes,
see.
there's your physical horizon, right? Right? You see the physical horizon?
Yeah.
That's how you think the sun is going down. But in reality, the sun is just going away. It's just going away. Let me show you. Right?
Well, like where?
Well, it's going very good. That's a great question. And I will show you in a moment. So sunsets. So let's see, what is this one? Yeah. So we see the sun, it comes towards us, it gets higher due to perspective, and then it goes away, and it goes, let me get rid of that. So this is how a side view of the sun would see. But when it comes towards us, we see it just getting higher, just like the streetlights, right? Imagine this guy's looking this way, the far streetlights here, getting higher and higher and higher. And then when it gets over him, it gets lower and lower and lower in the other direction. So we see it in a pyramid. But if we're on a ball spinning, like when you're watching the sunset, is the sun just moving away, or are you falling over backwards faster than the speed of sound? Remember, you're on the ball, you're watching the sunset, the ball's falling backwards faster than the speed of sound. That's what you have to believe. That's what you have to believe to be a globe believer, right? So let me show you. Yeah. All right. So here is, whoa, too many things open at once. What happened?
Now, also there is, because in relationship to what you're talking about there as well, the flights. So the Earth rotates from the west to the east.
Yeah.
Well, why is it that if you're on a plane flying flying into the direction the Earth, the opposite direction the Earth is spinning, why don't you arrive at that place faster? Because the Earth should be spinning in relationship to the airplane traveling above it. So it should make you get
I'll
there.
explain that from the glober point of view in a moment, but it's a bunch of mental gymnastics. And here's
because how do you know it just doesn't take that long?
Yeah. Well, Erica, just remember this. You're going to try to figure out stuff that I'm explaining to support your globe religion, and you're not going to be able to. But here's a very important thing. You're not stupid. It's okay. You're not stupid. It's stupid.
I love that. That's awesome.
Yeah, you can find that on my t-shirt shop on flatearthdave.com. All right, so here is my flat earth counter, and I have a string that's level across the counter, and I've got this light, and I'm walking from the far end of the room across. Here is the mountains, or it could be clouds, but the string is above the mountains. We're viewing this from a celestial view, which means up at the height of the sun, and you can see that it's going in a straight level path, right?
Right.
Okay, now I have a camera on the flat earth counter looking up, looking this way. And we're going to watch what it looks like from that point of view, the exact same scene. Now, when you watch the sun, are you watching it from a celestial level or a terrestrial level?
Terrestrial, for sure.
Of course. I just want to make sure we're just taking it slow. Okay. Okay. So here is the terrestrial point of view of the exact same thing. Now, if I showed you this first, I said, is this line level? What would you say?
Yeah.
It's level?
It kind of looks like it's slanted a little bit.
So it looks slanted. Is this sun going below this mountain?
No, it's going straight across. It looks like it is, but I already saw it.
You already saw, but if I showed you this first,
I would tell you that it was slanted.
And when I zoom in, look at this line. This line is level, right? It looks like it's almost going straight down. And if this is in distance, it will look like it's at your eye level. Now watch. Here it is going away. This looks like it's at your eye level. Here is the sun, actual sun. I'm just showing you the terrestrial view here. And what's the sun doing? Watch what happens right here. Ready? What's it going behind? Is it going below something or is it going beyond something just like this?
Well, that looks more like it's going beyond something.
It is going beyond something. But if I zoomed out, this line would merge with this line, and you'd think that you're falling over backwards faster than the speed of sound because you believe you live on a ball in a space vacuum, which breaks natural law.
Okay, but then why? What's the end game? Why tell us it's round?
That's a great question. That's a great question. And I can only speculate, but I know I'm 99.99999% sure I have the 100% the straight answer. But let's hold that off. Let's look at.
Yeah, thank you. Because it's incredible to me, and I don't mean to interrupt you, Dave. It's incredible to me that piece of like that experiment right there.
Yeah.
That example. I mean, I can tell that impacted you, Erica. And I'm not taking either side on this. I'm not saying get her, Dave, and I'm not saying get America. I'm just saying, like, it's amazing because I've had moments just like that. There's a video that Dave has. I don't know if he's going to show it or not, but the one that really impacted me, the two things that impacted me the most was the curvature, as far as like how many feet of curvature you have to have, like he was saying, at 3 miles to 10 miles. And the other one was the video of the pilot that recorded the flight.
It's a great one.
Yeah, I mean, that one was incredible, but like
the mental gymnastics that the globalists put out there, the refraction, tangential motion, this and that. The
refraction and the whole magnetic issue comes to mind.
Erica, hold on. We're going to go through each one of these things, but what your brain is going to do, it's going to scramble to hold on to the ball. Okay. So here we're on top of a mountain. The sun is setting. I got this yard post right here, and it's casting a shadow up on the building because the sun is setting. This mountain, let's say it's at 20,000 feet, no, 15,000 feet. I don't know, 20,000 feet high. It's high, but the sun across the plain is lower, so it's casting the shadow upwards. Make sense?
Yes.
Makes sense, right?
Mm-hmm.
So, I hope this is the right video. Yeah. All right. So I have, I'm shining a light on this water bottle. This one is going just away in a straight line, like I was making my sun along that string. And this one is actually going down like it's on a globe. Okay.
Okay.
So when I watch, the one that's going away never goes higher than the bottle. And guess what? Shadows never become higher than the object casting them, ever. Never do you see the sun reflecting on a ceiling of a house with a westward facing window at sunset on the top of a mountain. The sun never hits the ceiling unless, of course, it's reflecting off a lake or something. This never happens in reality. This happens where the shadow will go up and up and up, and then it just fades away and it becomes nighttime. This is what we experience in reality. This never happens anywhere, ever.
Why the picture?
Well, I'm just showing you a demonstration right here. And the picture, I put it together in Photoshop.
Okay. Okay.
I just wanted you to understand the concept. If the sun was lower, it would cast shadows higher. And anybody could do this. If you live high in the plain somewhere, find a straight wall and put a post next to it and watch the shadow, and the shadow will never go above the height of the post. It never even reach the actual height of the post. They get pretty darn close, right? And the next question you should ask is, well, if the sun's going away, how come it doesn't get smaller, right? It should get smaller, right? Like if this was the sun, it's pretty damn big. It goes away. It should get smaller and smaller and smaller, right? Shouldn't it? I'm helping you out here. I'm fighting for
yes, it should.
It should, except when something's already far away, it's already small. And I can show you that in a moment. So as it goes away, it doesn't get much smaller. But as it goes away, the perspective makes you look through more and more and more atmosphere. When you're looking up, you're only looking through a little bit of atmosphere. When you're looking forward, you're looking through all atmosphere. So as it's getting lower and lower into the atmosphere, that moist atmosphere is magnifying the thing that is getting a little bit smaller, but it's magnifying it a little bit bigger. It's a beautiful yin yang of how we see, but it doesn't happen all the time. It's different every day, right? Here is the sunset. And the sun is just, now here's the question. is the person filming this falling over backwards, or is this light, whatever it is, just moving away? It's just moving away.
Yeah, would say down. I would say it's moving down.
Going away. It's going down due to perspective, like the street lights,
right?
Like I showed you on my flat Earth kitchen. It's going away. It's not going down. It's staying right here, and then it's eventually just going to get eaten up by the atmosphere, and it's just going to be too thick, and its light is too local, and it takes its light with it. Right. So here is where
so if it's moving on a circuit, because technically what that's doing over top of the plane, it's when it moves away from you, it's actually circling, right? Because it's going in that circuit to
it's
go
going
to
in circle. I'll show you in a moment. So
Okay.
this is Chicago from the Indiana dunes.
So that's me. That's where I live.
You're okay. But
that's my beach.
At
least when I'm in Indiana.
On clear days with calm seas, see the buildings, but you can't see the buildings here until the sun goes beyond them and backlights them, right? And then all of a sudden you can see them. This tallest building should be below the curve of the earth, but it's there. They're all there.
And see, that was the example I was going to bring up. I'm trying to think of, like when I'm sitting on the beach, if it's clear, I can see Chicago. That's Chicago. That's the Sears Tower.
You shouldn't be able to.
And I can see it if it's clear.
So you shouldn't be able to.
Because it's 45 miles away.
Yeah, or 53, depending on where you take it from. But at that distance from the beach, you shouldn't be able to see it. So sun is just going away. It's going away and it's merging just like the streetlights did, right?
And when you say
I've never had anyone tell me I shouldn't be able to see it.
Well, that's because
on the globe.
Yeah, there was a famous picture by Joshua Nowicki, and it made the news. And the newscasters are like, well, you shouldn't be able to see it. Therefore, it's a mirage. And he did this famous thing. He goes, what you're seeing here is a mirage. It's like the biggest quote in flat Earth. And it's not a mirage. Mirages are wavy. We have time lapses of Chicago that go for like 18 to 20 hours. And if it was a mirage, the mirage would be all over the place. It would be wobbling and going all over. But it doesn't. It doesn't.
No, you can see it almost all the time from
because
the dunes.
The Earth is flat, right? So now here's what you have to believe, right? Here's what you have to believe, right? So I'm going to show you a quick example. We can see too far, and we're going to go to my favorite, the frozen lake, right? So large bodies of water at rest need containment. Can you take a bath if the side of the bathtub wasn't there?
No.
Okay, because the water needs containment. Anything over a cup of water, a gallon of water needs containment. If you spilled a gallon of water on the floor, it's going to spread out until it's so thin that it'll just remain a puddle. Or when you see a puddle, a deep puddle, the puddle has containment, the land that's higher around it. Pond has containment, a lake has containment, the oceans have containment. This reservoir is contained, and when it's calm, there's no wind, it lies flat, and when it's cold, it freezes flat. We put a camera on it 6 inches above the lake. And then we put these 4 lights out there, 8 miles, 7 miles, 6 miles, and 5 miles. Now, again, that doesn't sound like much, but remember at 3 miles, there's 6 feet of curvature. Now, Globers like to say, oh, you have to add standard refraction, which is like 0.02 or something stupid. Refraction means that the light is bending up and making you see it where you don't see it. If refraction was real, you wouldn't be able to drive down the road because buildings would be refracting into the road. It's so stupid, right? But I gave them 50% refraction, which is impossible. Okay. So, right. And at these distances from that height, giving them refraction, right? 30 feet, 22 feet, 15 feet, and 9 feet. Now that's how much curvature. That's a 3-story building. This light should be over a hill, 3 stories low. Now this is what you have to believe. A, Earth is flat. The camera 6 inches off the ground just sees the lights, 1, 2, 3, 4. Or in the heliocentric globe religion, the horizon is less than a mile away because at 6 inches, the Earth curves 8 inches in 1 mile. So 6 inches, we're gonna have a tangent to a blocking hill, the hump of the Earth, And you have to believe that each one of these lights refracted up a different amount to magically stop at the tangent line that this camera sees. Not higher, not lower. They magically refract up all their perfect amounts to line up, or Earth is flat.
Okay. Water containment? I mean, are you saying that we're physically containing the oceans?
Well, a lake,
A lake?
if you dug out the side of a lake, what happens to the water?
Right. The water.
Goes away.
Right.
Right. So what happens when you have water on a ball? It's but you're gonna say
it wouldn't stay, right? Without
gravity.
gravity. Right.
And how does
Right.
gravity hold it? Gravity can hold on to trillions of tons of water. Clouds that weigh more than air hold trillions of pounds of water, and they float in the sky. Gravity doesn't pull them down for some magical reason. I can hold my arms up. A bird can fly. A helium balloon will go up. Where the frig is gravity? Okay. Do you know what? Look it up. Gravity is a theory. Gravity is a theory.
It is. It is a theory.
Gravity is a theory. And then people say, well, mass attracting mass. That's all Newtonian gravity. They changed it to Einsteinian gravity, which is the bending and warping of space-time. You've heard that, right? The bending and warping of space-time. You know what it is? You know what the bending and warping of space-time is? You could say no, because nobody knows. It's no thing ever. It's stupid. Okay. It's stupid. You're not stupid. The bending and warping of space-time, they show you a bowling ball on a trampoline. How come it's going that way and not that way or that way or that way or that way? Right? Why does space bend in one direction? They put a bowling ball, on a sheet that's covering a tube, whatever, and they start rolling balls around and they're going around like those are orbits and everything. Full effing S. Okay? It's so stupid.
So
Right here, I want to show you how crazy flat earthers are. We think that we live in an enclosed world. Most of us do, or there's some sort of containment. And down is this way for everybody. South America, Australia, America, right? Africa, right? Down is that way.
Okay.
Right? We're crazy because in reality, down is this way. This guy's antipodal to this guy's here. Now imagine this ball is spinning. You know what centrifugal force is, right?
Yes.
So these guys, let's say these guys are on the equator, they're going to be lighter because the centrifugal force is going to push them outwards.
Right.
This guy here, he's going to be pushed over towards the equator because the spinning is going to make him tilt over towards the equator. This guy is pirouetting like a friggin' ballet dancer, okay? This guy's moving 1,000 miles an hour. This guy's just pirouetting. This is nonsense. And here's the thing, Erica, you never thought about this stuff. It's not your fault because they told you the earth was a spinning ball and they moved on, right? Let me ask you a question. What's the circumference of the earth? What's the radius of the earth?
I don't know. I think I did learn that at one point, but
how fast is it orbiting?
Fast.
That's a good answer. Right? How fast? Did you know that it's chasing the sun too?
No.
All right. Oh, so you have to believe, right? This is crazy. There's so much I want to talk to you about. So they teach us that all of the planets go around the sun, right? And the Earth goes around the sun, and Mercury and Venus are closer. They go around the sun,
right?
Mars and Jupiter, and all the way out, right? Do you know that they're all on the same plane? They're all on the same plane. They all if this is
right. According to my model, they're all at different.
They're at different distances, but they're all on this same flat plane.
Right. That's true. I agree. That's how I know it.
Do you know it's weird? You think it's weird?
Yeah. Okay. I don't know if I thought of it as it can't possibly be like that, or if I thought of it as, well, that's the easiest way for us to understand it is they're all there. Maybe they're not really level, but.
Well, they're all within a couple degrees of each other. That's what they tell us, right?
Right.
So we're spinning at 1,000 miles an hour, which is faster than the speed of sound. We don't feel it, right? We're orbiting at 66,600 miles an hour on average. It speeds up and slows down, but 66.6, that's a funny number. Okay. And while we're doing that, the sun is motorboating through the cosmos at 500,000 miles per hour. But somehow all of the planets stay on that same plane and follow the curved trajectory of the sun. And everything works perfectly like a clock. Perfectly. Never changing. Finest timepiece in the world. Is it the Swiss watch or is it the solar system? Which one?
What you're saying right there is not possible.
This is not possible.
No.
That's what they tell us. This is the heliocentric hypothesis.
Yes.
The constellations remain the same too. They don't.
Everything. Wait. So this sun is traveling 4.5 billion with a B. That's a big number. Miles per year, never to return to where it was before. All of the other stars in our solar system, in our galaxy, 100 billion of them, whatever. They're in 80% of them are in binary orbits, which means they're going around each other while they're moving through the solar system. Some of them are in trinary, which means they're doing this craziness, right? And never in all of recorded histories have two stars ever changed place due to parallax. How things closer move faster, right? Never, ever, ever have two stars ever changed. The constellations are still the same, right?
And based on what I know about the human brain, that model is not possible. So what you're showing right there would not work.
Right. This is, let me show you this one. This is a hypersonic sled track. Right. NASA's got this rocket sled watch. It's going to go by at Mach 8.6. Didn't even see it. Right. If you heard the sound, it's literally shocking. Like the shock wave. Mach 8.6. Right.
Right.
So you have to believe we live on a lumpy rock. Right. You ever see a picture of the Earth with all the water gone? So we live on a lumpy rock that has curved, smooth water on it. 70% of it curved, smooth water that no one's ever measured that curve. It's spinning. Okay. It's got high pressure air surrounding it that's not contained, adjacent to no pressure of space. You know what? High pressure and low pressure can't exist next to each other without a barrier.
Right.
So that's all happening. And you're watching this rocket sled. We're going around the sun 10 times faster than this. So that lumpy, rocky water ball is going around the sun 10 times faster than this, right? And it's chasing the sun 100 times faster than that. It's moving in 4 directions at once. But when we go out in nature, we see stuff like this. Now, nonsense tells you, I was just telling you the nonsense of the heliocentric hypothesis. What does your God-given common sense tell you about these lakes?
They're not moving.
If you were in a car, 100 miles an hour, perfectly smooth road, great suspension, cruise control's on, it's at the exact speed, you got a dinner plate, you filled it with water. No problem, right?
Mm-hmm.
If that car took the slightest turn, what happens to the water?
Oh, it's all over.
Right.
It's done.
What's going on here?
I've certainly been to Lake Louise up in Canada. I know it doesn't move, right? You can see the glacier off of it. It's not moving. But nothing's moving.
No, I'm not moving. 4 different directions at once. You're spinning at 1,000 miles an hour, orbiting at 66,000 miles an hour, chasing the sun at 500,000 miles per hour, and our entire solar system's moving sideways at millions of miles per hour. Every day, all day, and all those directions are not straight lines. They're all curves. And when you curve, that's acceleration.
Yeah.
You feel that, right?
Yeah,
things going on, and no one has ever sensed it, ever. No one's ever measured it. Every test to prove axial rotation or curvature has proven the opposite. And you still believe we live on a ball.
Wait, we don't have tests that show?
No. There's major tests throughout history that prove the opposite. Aries failure, the Michelson-Morley experiment. I don't want to get into all the details of that, but the one that you might remember that they taught in school is Eratosthenes. 2,000 years ago, the Greek guy that figured it out with his sticks and shadows.
Yeah.
Let me tell you the story about Eratosthenes. One day he noticed in Said that on a certain day of the year at noon, he could see the reflection of the sun in the bottom of a deep well. And he concluded that that means that the sun at that very moment is directly above that well. Good. That's good science, right?
Right.
Right. So he came up with an idea that maybe if the Earth is curved, he figured that the Earth, well, they supposedly they knew that the Earth was curved, but if his friend went somewhere else on the Earth at the same time, and they both put a stick straight up and down, if his stick had no shadow and his friend's stick had a shadow, right? Because if I got a light above here, right, I got the ball, and I have a stick here, there's no shadow, but a stick here would have a shadow.
It should.
Right. So first, Eratosthenes lived in a time when they believed that the Earth was a ball, but it was geocentric. The sun went around the ball. The sun went around the Earth. That's what they believed when he did it. So that would mean we need a local sun. But when they say that the sun's so far away that the rays appear to come in straight, right? It's so far away, right? That the rays appear to come in straight. Well, no one's ever seen rays come in straight. Whenever you look up and there's holes in the clouds, you see stuff like this. Okay. What does that tell you? What does your geometry class tell you? Where's the sun? Is it 93 million miles away or is it way closer? Right. So there's no parallel rays, but let's just pretend that for some reason he thought there was parallel rays. So he got his friend to walk 500 miles and count his steps. That's how they measured, by counting your steps. Did you count your steps for 500 miles?
I mean, that'd be really far, but yeah.
Okay. So he counted his steps. He didn't lose track. You know, he probably he had to come back a couple times and recount. Right. So he gets there. And so now they have some way of communicating where they can both do their measurement at the exact same time. What did they use for that? You know what they use? I think they had a cup with a string. Hello, you know,
it's a 500-mile cup with 500
miles with a cup of string. I don't know. This was 2,000 years ago. So there somehow he put a stick up and he could measure it, and he did some really good math, and it determined the shape of the Earth. And now they say Carl Sagan on the show Cosmos, he really drove it home. He said Eratosthenes figured it out within 2% of what current astronomers mean. And he's like, if both of those didn't have a shadow, what does that mean? He goes, but, and he's going to show you in a second. He goes, if you bend it, hold on, they get it. He goes, let me go back a little bit. He goes, if you curve the Earth, so this one doesn't have a shadow, and then you bend it, you can do the math and figure out the length of the shadow and figure it out. Great math, actually accurate math.
Yeah, if it's curved.
If it's curved. But his friend said there was a shadow and he didn't have a shadow. So is that the only option? Well, first, there's no such thing as straight rays. And so on a flat Earth with a small local sun, we have the sun right here. Here's Eratosthenes. Here's his buddy over here, and there's a shadow. You can do the same math and figure out the curvature of that flat Earth. You can do this in your own house. I got a beer bottle here. I got a light directly above it. There's no shadow. There's a shadow over here. I could do the same math and figure out how curved my floor is. It's the same math. Math is not reality. Math is just a tool to describe things.
Well, the numbers don't change.
Yeah.
So that's a static measurement of a process.
To this day, they're teaching kids that Eratosthenes absolutely proved that the Earth is curved by the sticks and shadows, but they don't want to look at the flat Earth model, which shows the same thing. It shows the exact same thing. Exact same thing.
I just don't know why. Like, it doesn't make sense that you would have and perpetuate such a crazy theory for what?
For what? What's the purpose, right?
Yeah, because why teach everyone something different? Why hide something? I mean, we already know that there's a lot of things that we thought we knew that we don't.
I'm going to show you one more thing, and then I'm going to deeply get into that answer for you, okay?
Okay.
Deeply. So with today's consumer optics. Where'd you go, Aaron? Don't go away.
I'm right here. It's gonna blow my nose.
Okay, I'll allow it. So here's Sirius to the naked eye, and here's Orion to the naked eye. Then we could zoom in and we can make it, wow, we could really zoom in on this star. Okay. This star is 50 trillion miles away, and I'm able to zoom in and make it bigger. That's kind of weird. Okay.
That's, yeah.
Kind of weird. Trillion. Do you know how much a trillion is?
It's, I mean, with a telescope, right?
How much is a trillion? This is a camera. This is just a camera, right? How much is a trillion? How long is 1 trillion seconds? Do you know? Just to show you how big a trillion is. How long is 1 trillion seconds? If you can say within 2 days, I'll give you $1,000.
I don't know.
Years.
No, it's 31,000 years. Okay. Okay. 31,000 years. That's 1 trillion seconds. This is 50 trillion miles away. But we're able to zoom in on Orion too and make it almost the same size. And because we can zoom in on it, that means if it's almost the same size, that means that Orion, because it's 52 million times farther, 52 million times farther than 50 trillion miles. This is where your brain melts, okay? So Orion would need to be 52 million times bigger than Sirius for me to zoom in and make it that big. Did you follow that?
Yeah, you can't do that.
You can't do that, right? Because here's the other thing. I can zoom in on the moon and bring it in focus. I can zoom past the moon out of focus. I can zoom back to the moon in focus. I can zoom before the moon out of focus, right? I can do that with planets. I can do that with stars. The funny thing is I can do it with the sun. I can zoom in on the moon, get it in focus, swing it over to Saturn. It's in focus without changing the focus.
On just a regular camera? Like not with my phone.
Probably with your phone too, but with absolutely.
Like at 35 millimeter digital.
It's a digital the Nikon P1000 camera is the camera that is literally crushing the globe. All right.
Wow.
So let me ask a question. You have a job?
Yeah.
Okay. And are you paying your bills?
Mm-hmm.
Right. And would you say that fuel for your car, heat and air conditioning for your house are big parts of your budget?
Yeah, for sure.
What if all of that was free? What if there was free energy? What if you had a device the size of your fist that you could air condition your house so there's icicles on the window in July, and you could heat your house in the winter so it's like a sauna and you could do hot yoga, and your car can run for generations? Would that change your life?
Yeah, it would change everybody's life.
Okay. So what if there was more land? What if there was other civilizations? What if there was more resources? What if you found out that you're not a random speck that evolved from pond scum, turned into a fish that grew legs, found another sexy fish, had a monkey, and the monkey had a human? That's what they teach you in school. What if you found out that you're at the center of creation? What if you found out that there's unlimited resources? What if you found out that we're not overpopulated? Overpopulation is a joke. Okay. And what if that's just the beginning, right? But they don't want you in a position where you can't deny intelligent creation. Okay. They want you in the Big Bang world where you can say, oh, yeah, well, God did it. Or no, it was just a Big Bang. They don't want you in a position where you understand that this place was created for us. We don't live in a solar system. We live in a soul system, a system made for souls to have experiences here. Right. And once you start seeing all of this, you start seeing everything. You start understanding that we are eternal souls here, in my opinion. You find out that we are here with a mission. We came here with a plan to get somewhere, and we have free will. We can go off that plan, but anytime we go off that path, it gets harder and harder and harder until we turn back, right? We still have free will. We can do whatever we want, but we came here with a mission. This is how I see the world, right? Others might disagree, right? So
this like on our own, or we were brought here?
We were created. We're here. I believe, this is just me. I'm not speaking for anybody else. I think our eternal souls are in the stars, right? When we look at stars, right?
Yeah.
What is a star? A star is a burning ball of gas, right? In a trillion, 200 trillion miles away, right? This is a star. That's a star. Does that look like a burning ball of gas in a space vacuum that I'm able to zoom in on and see?
No. I mean,
No, look,
yeah, because
look at all
that's
these
what
stars.
what I've been told. But
This is
like,
what
this
you've
is
been
what a ball
told.
of gas looks like when it's burning.
No, this is not what a ball of gas looks like when it's burning. And by the way, our sun is made from helium and hydrogen. Now, helium, how much do helium and hydrogen weigh on Earth? They defy gravity. Fill a balloon
Right.
with helium or hydrogen, it goes up.
Right.
What happens when you take a container of gas, helium or hydrogen or air or whatever, and you go into a room that has no air and you open the lid? Instantly fills the room, right? Instantly equalizes. Except in space. In space, helium and hydrogen collapse, turn into nuclear furnaces that burn for billions of years. Our sun is burning 640 billion tons of helium and hydrogen every single day for billions of years, and it's not getting any smaller. It has
That's
enough
not possible
gravity
either.
to hold on to Pluto, but when our moon comes around the Earth towards the sun, it doesn't pull on the moon. And when it goes away from the sun, it doesn't slow it down. This stuff is ridiculous and stupid, right? So going back to why the lie, we are these incredible, powerful beings, and we have connection to everything. Everything's alive, including rocks, okay? When you understand what this place is, everything is electric, magnetic. We are electrical beings. We're in this electrical system. The moon controls your cycles. The sun controls men. Okay.
I agree with all of that.
Yeah. All of that's
all
happening.
of that.
We have all of this connection, right, to an infinite plane of existence with stuff above us, stuff below us. And who knows how far the shoreline of our world goes. I think the shoreline might be an infinite plane, right? But when you put a globe thinking you are confined, you have limited resources, you're living in fear, which is false evidence appearing real. Live on a ball, you have to abide by their ball field rules. It's literally a prison for your mind. And because your thoughts create your reality, and when you're in a ball prison, you can't think outside of the ball because
that we did to ourselves.
I think that there's fallen angels, Satan, whatever it is, that rules the world, and we have free will. There's not many of them, and there's many of us. So they get us through deception. All people in power, all the governments and stuff, they're all satanic, crazy,
Agreed.
Yeah,
I agree.
and,
right.
And
yes.
they're literally run by Satan, if you will, right?
Yeah. Or people
they want our souls. They're literally trying to steal our souls. That's why maybe they call it the soul lure system, right? So when people say, "Well, who are they?" Right? You got the Council of Foreign Relations, the Trilateral Commission, the Royal Institute of International Affairs, Club of Rome, the Bilderberg Group, the United Nations. Those are the ones that we know of. These are the puppets of the fallen angels, if you ask me.
Oh, my brain hurts, Aaron. God.
I mean,
do you delve into I feel like I've manipulated this whole interview. Go ahead, Aaron.
No, please. This is fantastic. I love it.
So
do you delve into where people bring like the Book of Enoch or the biblical parts of it into it where like, hey, it's all right here. What, you're missing it. Do you go there too?
There's so much, right? But here's the thing. When you Google flat Earth, you're going to get fed all propaganda. You know that the Google and the government and the news steers your mind north, east, west, south. News, right? It's here to steer your mind. Truth in the movies, lies in the news. Everything is inverted. Everything, right? What happens when you take a ball away from a baby? Right? Doesn't go well, right? But they indoctrinate us into the ball religion before we have the ability to discern, before we know that our teachers might not be teaching us truthful information. Teachers aren't liars. They're indoctrinated. How do you become a teacher? Don't question, study, memorize, regurgitate, and you could become a teacher. Who wrote the books? The Rockefellers. They want the best for us too, right? Right? And how do you make a big baby crab. Okay. Right. So people like to cling on to their ball, right? There's something about it. It's kind of cool. Space. But you know what's amazing is outer space. Right? Now, again, we don't need to speculate what's beyond where we can't go, but I love doing it. Right? What if the world is set up like this? Whoops. I forgot to switch over. What if the world is set up like this? Right? Here we are, right? South America, America, right? We're here. What if this is Antarctica? And we have more land out here, other civilizations. Maybe the Atlanteans are out here, right? What if there's more land out here? If somebody lived on this extra territory and they came to visit us in here, what might we consider them?
Extraterrestrial.
From where? They came into this space. So where'd they come from?
Out there.
The outer space.
Why wouldn't okay
so
why wouldn't they come more often? Like they just don't like
here
us
every day. How do you know that Aaron's not an extraterrestrial? You don't know.
Well,
okay?
I have suspected.
And he might not even know. Okay. We only have a couple minutes, but I want to do something I haven't done in a long time. I want to show you something about that happened in Antarctica. There's a lot of interesting stuff. Right, you know about Antarctica at all, Admiral?
Yeah,
he found more land bigger than the United States that no human has ever stepped foot upon on the other side of their base, other side of the South Pole, which would have put them between Australia and and Africa. So, do you think that the people in Australia and Africa would notice land bigger than the United States? Right,
you would think so.
That doesn't make any sense whatsoever. So let me just get to this area here. And all right, so you can go on a ship tracking site and you can see all the ships in the world, cruise ships, you can track them. They're everywhere. Amazing. And we found a ship that was 730 miles from the shoreline of Antarctica. How did it get there? An active ship, right? And at that distance, it's 1.9 miles higher than sea level. That's weird, right? We found another ship 905 miles in. Right. And that one is 2.37 miles higher. Like, how do active ships get in the middle of Antarctica? Is it really melting? Like, how can that be? How can that be? So we hold on. This just hold your horses. So this map was found in a Buddhist temple, 10 centuries old. It was published in 1907 or something in a Hawaiian newspaper. And it shows the world with all of these extra continents out here. Okay, just keep that in mind. Okay, right. So we looked at when you click on the ship, it tells you where it's going, a company that owns it, nation. It gives you tons of information. When we clicked on the ships that were in Antarctica, all it said was their size and what nation they were registered to, which is weird. Wouldn't say where it's going. And it was registered to the nation of Kiribati. And it said it was 850 meters long and 80 meters wide. Okay.
Wow.
A gigantic ship. So
that's huge.
Where's Kiribati? Out in the middle of the South Pacific. I had to put a pin on it because it's so small. And the United States, China, Vietnam, they say that this is a very important trade route. Okay. This is what? Why is this an important trade route? Okay. Now look, Kiribati, Kiribiti. That's what it's called. All right. It's pronounced Kiribati, but I don't care. It's spelled Kiribati. Right.
Right.
So keep that in mind. All right. So we looked at the ships that were docking at their massive pier. Like, why do the United States gave them $10 billion not that long ago. And we saw that all of the ships here, their destination was either unknown or Christmas Island. What is that about? Right? Where are they going? And these ships go into Antarctica from here. And so, like, what the hell is going on there? There's some stuff, I don't have time to get into it, where Kiribati was nuclear testing was done there. If you know about the nuclear hoax, that's another thing. But our video started going viral, and all of a sudden, you couldn't find Kiribati on Google Earth. You search it, it brings you to this island. which is on way over here, when Kiribati is over here. And they changed the name to Karamati.
Okay? What?
They changed the name because these videos were going viral. It's now Karamati. Right?
Oh, so, Dave, do you feel safe?
God's got my back. Okay. So we're almost there. We're almost there. How many time zones are there?
Oh, I don't know. 12?
No, there's 24. So,
okay.
So the Earth has 24 lines, on the ball from the North Pole to the South Pole, dividing it up like sections of an orange, right?
Right.
And then as the Earth spins, wherever it's facing the sun, it's noon at that point. Makes sense, right? Makes sense. Yes? Makes sense?
Well, yeah.
Right.
Yeah.
You know that in reality, there's 19 time zones in the north, 24 between the two tropics, and 32 in the south. Isn't that weird? You never knew that, did you?
No.
You never knew that, right? So going back here, where's my thing? Ships. Okay. There we go. All right. So we go back to this map. What if it was an important trade route and they went from Kiribati out here? And so this ship is trading weapons, food, tuna fish, children, I don't know, with other civilizations out here, other resources that they don't want us to know about. I think maybe they're trading computer chips, right? Because we had some guy that worked for one of the big chip manufacturers, and they're like, yeah, we improve the chips, and they spend months and months and months and months and months trying to make minuscule improvements to these chips. And then the industry goes, hey, we need a chip that's 10 times faster. And the guys scratch their heads and they're like, what are we going to do? And then the CEO comes out and goes, here, try this chip. And it gives them a new chip that's 10 times faster. And then they work on that chip for months and months and months and months and months. Where did they get that chip? Where did it come from? All of this technology that we're experiencing now is old technology. It's old.
I do think that. I do think there have been civilizations that had far surpassed the technology that we have. Even if just based on if you go back far enough and what's been buried, there was irrigation at a time like 4,000 years separate from when we then had irrigation again. And why did it take us so long to learn it? Like, how did we forget that we knew how to irrigate?
All right. So here's
what about the people on the ship? Like, it's kind of like the
you
whole
don't know.
thing.
You don't. There's lots of people in the know. Who knows what's going on here? Who knows what's going on in North Korea? Have you ever been there? Right? You don't know anything. Right? You don't know anything. Here's the thing. I fed you with a fire hose, and now you don't know what to do. Okay. FlatEarthDave.com. There's the playlist there that says a crash course, and I recommend people to start watching that. I created this app which bypasses the algorithm, and what I tell people is just every day click this thumbnail and there's a new video while you're having your tea or coffee. Just watch one short video a day. That's all you got to do. At the end of that 2 weeks, if you still think the earth is a globe, send me your proof and you win 3 Bitcoins. All right. But before you do that, you have to hit the question mark button, which is right there. And up comes the frequently asked questions like, what about eclipses? Where do boats, where does the sun go? What about tides? What about the 24-hour sun in Antarctica? What about the International Space Station? There's all of the frequently asked questions are there. But what I want you to do is click the Griffin button. Okay. The Griffin right there. And this is old world stuff. And I want you to watch this video here, Old World Order. You can find it on my website also. And that's an introduction into the old world. What do I mean by the old world? Do you know that remember the story of Lewis and Clark that crossed the Mississippi to go find a new trade route to the West when they were in America? You know that Chicago and San Francisco and other cities were already fully built out?
San Francisco?
Fully built out with buildings that we couldn't even repeat to build today. And all of the wars and fires that you hear, the Great Chicago Fire, that every city had a great fire, every city all around the same time. Okay. Just search your city, Great Fire. And you'll find out it's the same thing everywhere. Here's what I want you to watch. It's a channel called My Lunch Break. It's on YouTube. It's on Rockfin. It's everywhere, right? It's on Rumble. My Lunch Break. Just start watching a couple episodes of that. That's all I
Okay.
ask you to do. Just
I mean, I don't know if you know how dedicated I could be to trying to win
you,
3 Bitcoins.
yeah.
I'm going to end up becoming a flat earther just
You
because I
already are
was
a flat
trying
earther.
to get
You already
Bitcoins.
are. You already are. That's how you become a flat earther. That's how I became a flat earther. I tried to debunk it. Right.
Yeah.
There's if you're on Telegram, this guy's great. I'm the Improbable Dreamer. We got Autodidactic Campbell. He's amazing. Old his story, right? This guy's funny as hell. He swears a lot. Just laughing at the stories. And then after you watch a couple of My Lunch Break and these other ones, you're going to go out in your own hometown, wherever you are. You're going to walk around. You're going to go, how did I miss that? How did I miss that my whole life? And you're going to walk around. Your jaw's going to be open. People are going to think you're crazy. You're never going to be bored again. And you're never going to sleep fully again. Welcome to Flat Earth.
I mean, they already think I'm crazy.
All right,
But
Erica.
yeah,
Did I move you a couple % away from the ball? You don't have to say the Earth is flat. You can
no,
say
yeah, I have problems
ball
because
is ridiculous.
yeah, I have problems. There are definitely some things you said where I'm like, okay, I need to take a minute and think about that. And maybe I agree and maybe I don't, right? Where I'm like, I'm still trying to, because no way. Come on, Dave.
No way.
But I can't just
listen, it's because here's the thing.
I can't just say no way because I'm not dumb.
When you say I can't believe, it's because you can't believe. But you believe you live on a ball. Give me one reason. What's one proof? And you can't say somebody told me. And you can't say NASA because I can just totally debunk NASA. They fake the moon landing, they fake the ISS, they fake rocket launches, they fake everything.
No, I don't have a reason anymore.
All right.
Because now I talked to you. My reason was, well, that was just that's what I'm told. I already told you I don't have a valid reason for thinking that other than
Erica, welcome to Flat Earth.
I mean,
Aaron, sorry I did all the talking and Erica, but I hope you had a good time. We'll do another one, you and me, if you want.
Oh no, this was absolutely incredible. This is exactly what I wanted. This was amazing.
All right. I hope I moved you to 82%.
Hey, you know what? I definitely I ticked up a little bit on that. So all right, brother. All right. I really appreciate your time. I know it's past your time to stay with us.
FlatEarthDave.com. That's where you can find my app. The app's $3. Lifetime. You get it for $3. If you want to use the social media, if you want to send messages, if you want to create meetups, you want to do all that stuff, it's $11 a year. Okay. But you can also earn by referring it to people and earn a free subscription. So it's super cheap, super helpful. I could use the support because the app costs a lot of money and it's waking up a lot of people. And the powers that be are doing everything they can to stop this app because this app is waking up too many people. It's bypassing their algorithm and they don't know what to do. So they are attacking me super hard. You're going to see troll comments. Dave's app is leaking data, right? Let me tell you what data it leaks. You know what KYC is? KYC is when you're filling out like a Bitcoin farm or account, you have to verify your identification. You have to show your passport or whatever, right? This is non-KYC. You can put a fake name, fake email address, and any information you put in there is information that you want to share with the other users. The only information, let me say it again, the only information you're putting in there is the information that you want to share with other users. So they spent a lot of money hacking into my server, which we fixed. That was back in October. We fixed that. They could have just paid the $3 and just looked at everybody's information, right? It's like I'm going on Facebook. I'm going to hack Facebook so I can see what you're up to. Well, I could just go to the page and look at what you're up to.
Right?
It's so stupid. They want you to believe that the AE map is dead. Erica, I didn't even show you this. The sun goes around just like this. And right now it's equal day and equal night because we're right near the equinox, but that changes every month, right? And the sun chases the moon. You'll see that the moon is coming out behind the sun slowly. There it is. So the sun will lap the moon every 28 days. So the sun keeps track of the hours and the days. The moon keeps track of the weeks and the months. Maybe there was 13 months of 28 days. That's 364. One day.
I think there was another month. Yeah. I do think we're missing a month. And
that way, all the months are 28 days. That's 364. And then on April 1st is the new year. That's why they call it April Fools. And then if you turn the stars on, the sun is going slightly, the stars are going faster than the sun, but they take 365 times around to lap the sun. So the sun will drift back into each zodiac for about a month. So the stars keep track of the seasons and the years.
And that's ancient wisdom as well. That's actually in the Bible, by the way. Like when it talks about God creating the great lights to rule the day, the lesser lights to rule the night, all of that was for the keeping of the months, the days, and years, etc.
There's a biblical section here, and you go here. There's amazing stuff. A lot of random videos in here, but this biblical cosmology remastered, amazing series. But it's long, not that long, but it's really really good. So you have to sit back and dig in, and if you want to learn about the biblical cosmology, this is amazing. And every Sunday, Marty Leeds does this Gnostic church. It's amazing. He's a flat earther and he gets it, and the stuff he teaches you is better than any that you'll learn anywhere else. It's absolutely amazing. And go check out some of his old sermons. He's actually taken a couple of weeks off right now, but just check out his sermons. They're amazing. They're absolutely amazing. So there you go. Thanks for having me. FlatEarthDave.com. Erica, welcome to Flat Earth. Aaron, you're already a flat earther. You just were trying to hedging your bet there with 81%. Come on. Okay. All right, man.
Thanks, Dave. It was great meeting you.
All right, bro. Thank you so much, Dave. This has been fantastic.
All right. See you.